Today I'm going to cover how you might train other languages in Tortoise TTS. This is assuming that you are generally familiar with the training of Tortoise TTS, and if you're not, I have some previous videos that I went over for the Tortoise TTS training or the AI voice cloning repository, so go check those out first if you're new to all of this. First, I'm going to go over my successful training of Japanese, and so here it is. I have the AI voice cloning repository open. I'm going to first play an audio sample of the actual voice that I trained on, and then I'm going to play it reading out the input prompt using the model trained on that voice. So I'm going to generate a new sample, and this is the short little sentence that I am reading out right here. And so here it is. What I'm going to do is play the audio sample first of the actual voice reading out this sentence, and then I'm going to play the generated sample. So first the actual voice sample, and then second will be the generated sample.
期待してるし、信じてるよ。期待してるし、信じてるよ。
So there you go, a short little sentence, and I can also do it on longer sentences, so I'm just going to go ahead and paste this in here. Going to regenerate a sample and then play it through just to show that it is coherent in its speech and is able to do it without too much issue.
許す許さないの話になるなら、俺は絶対にお前を許さない。でもそれは俺の心の問題だ。
So that is pretty good. And this is a Japanese model trained specifically on Natsuki Subaru from ReZero. And so what I ended up doing was fine-tuning this based off of a successful Japanese model that I trained. And how to train that language model is what I'm going to be discussing and talking a little bit about in today's video. So let's go ahead and jump into a little bit more of the nitty-gritty on how I actually accomplished this. First off, there are a couple of things you need to train a new language in Tortoise TTS. You need a lot of data from the language that you want to train on, and then you need a tokenizer. For me, the tokenizer was the hardest part of the process and understanding how it worked. So let's go over a little bit of what tokenizers are in reference to Tortoise. So in order for Tortoise to understand what words actually are, it needs to break it up into different pairings or tokens. And so inside of this tokenizer, we have 255 different pairings that allows the model to relate these pairings of words to audio that is trained on. Now, if you want a little bit more of an in-depth explanation on what bypair encoding tokenizers are, there is this nice Hugging Face tokenizer summary page that you can go to. I'll link it down below in the description if you want to read a little bit more about tokenizers. But for Tortoise, we have a special tokenizer that is 255 characters wide, and this is specific towards the Tortoise architecture. I believe if you try to train with a tokenizer that is larger than 255, then you end up running into errors, as is what I was running into when I was trying to train Japanese using the one provided by MRQ, who is the author of the AI voice cloning repository. Now, instead of actually creating a new tokenizer for Tortoise TTS, I decided to just use the standard one that is already there, which makes my life a little bit easier. And so what I needed to do now, if I wanted to use the standard tokenizer, was to convert my dataset transcriptions into text that the tokenizer would be able to encode for Tortoise TTS to be able to understand. And so let me just give you a quick example for the importance of the tokenizer actually representing your dataset. So here I have a sentence, and here below I have the Latin conversion of the sentence. Now, if I remove this and go ahead and tokenize the text, here is what you have. And so what's going to end up happening is for this bypair encoding tokenizer, it's going to be pairing these two characters to this audio sample. Just a brief explanation on how Tortoise trains. It finds the audio file, and then it finds the transcription for the sentence at that audio file. If these two are mismatching, say for example, instead of this sentence here, you change it for a bunch of gibberish, what it's going to end up doing is mapping the contents of this audio file to this gibberish right here. Hence, it won't be able to actually read it out correctly. So what I mean by that, if this is tokenizing katai right here as GU, in order to actually get the model to say katai correctly, I would probably have to type GU. And then so when I go to generate, this GU combo would equal katai. But that makes it impossible for us to use because we want to generate with accurate text here. And so with Japanese, this gets very convoluted because there are thousands of different combos for kanji and different pronunciations, which makes it very hard to do without creating either your own tokenizer or using the one that's provided. And so I went the easy route. I was not able to make a tokenizer for Japanese, But instead, what I ended up doing was just converting all of the Japanese text into what's called Romaji, or the Latin equivalent of the Japanese text. Now, I think what you can do is, if you're training, say, another language, you can simply just convert all of that into the Latin alphabet and train on that language. For example, if we take like a Spanish sentence here, and we go into the tokenizer, it looks like it does tokenize it correctly. So I think you might be able to train Spanish as is. Now, if not, you might have to make a custom tokenizer. I haven't tried other languages yet. This is just my experience so far with Japanese. So you want to make sure that whatever text you are tokenizing is matching your audio samples. And with Japanese, you have to turn it into Latin characters. I believe the same might be with Chinese and other languages that don't use the Latin alphabet. Now, for the details on how to go about the training, I'm going to go ahead and just go over what I did, and maybe you guys can take some inspiration from that as well. So my dataset consisted of 840 hours of Japanese audio. Now, I don't think you actually need that much, but that's the amount that I trained on. I heard a crazy number like you need 10,000 hours of audio data. I did just fine with 840. You could probably go with a little bit less. But what you're trying to do is represent the entire language with as much variety as possible, because you're trying to get the model to understand how the language sounds when these tokens are combined together in different formations or pairs. So that's where the byte pair encoding comes in. And so what I did was I prepared the data set. If you're preparing a very large data set, you might run into some issues with the prepared data set part here. So I ended up using a custom dataset maker outside of Tortoise, outside of the AI voice cloning repository, just to make it a little bit quicker. I'm not going to be sharing it in this video. I will be sharing it maybe later on for the script that I used to make the dataset. But the important part for the dataset is you want it to match the files that Tortoise requires. So if we go into, let's say, this MP3 JP corpus, which is the Japanese model that I use to train, this train text file contains all of the transcriptions for those audio files. And so the format of the training folder is training, then the name that you want to use, then a folder named audio where you have all of the different audio samples in here, and then a train.txt file where inside of this train.txt file you have the path to the audio file. So in this case it's audio, and then the name of the MP3 file, and then the transcription for that audio file. And so if we go into this audio file here, the audio inside of this file is going to match the transcription right here. And so that's what the script does. And then validation is just taking a small sample of that train.txt file and putting it into validation if you enable validation, which I did not. Now, if you've been training in Tortoise, you can just prepare your data set in here. This one works fine for 5, 10, 20 hours. This works just fine for that. Now, the generate configuration tab is where you want to change a few things for training another language. Once you have your data set all up and going, if you have a lot of data, in my case, I had 140 hours, I only set it to 10 epochs. So depending on how much data you have, you can change this, and depending on whatever GPU you have. In my case, I just did 10 epochs. And so this 10 epochs for 140 hours was going to take me 2 days to train. Now for learning rate, what I found to be most efficient was cranking learning rate all the way to 0.001. I had originally tried to train at the default value, but it was training way too slow, and the model that came out of it was actually subpar to the successful model that I trained. In actuality, I really only had to train on 1 epoch before my model converged to a Japanese model that I thought was particularly good. And so I explained this a little bit in the video before, but the one that I trained at a higher learning rate, which is this value right here, actually sounds better than the one that I trained for longer at the lower learning rate. So this is one thing that you have to play around with a little bit. But for the initial model, if you're training it on a language, I recommend cranking it all the way up. Mel learning rate ratio, that stays the same. And then text learning rate ratio, you want to crank that up all the way to 1, because what you're doing is you're retraining the model on how the text to audio should actually sound. And so this is very important for the language. You're trying to change how those text tokens are converted into audio. You're trying to change that from English to whatever language you're going to be using. For a learning rate scheme, I ended up doing cosine annealing with 4 learning rate restarts. And cosine annealing looks like a cosine wave. If I go into this training here and view the losses, this is what cosine annealing looks like. So it goes down and then it goes back up to restart, down, goes up to restart, and then it starts getting a little funky here because I'll explain a little bit later. And then for batch size, my GPU allowed me to do 128 with a gradient accumulation of 16. I recommend you put this at something like 64 and then click on this validate training configuration. So let me go ahead and just go into this JP corpus here. Let me reuse import this dataset. And I recommend you just click on this validate training configuration because it'll automatically calculate what gradient accumulation size you should use for whatever batch size you want to use here. So let's say instead of 128, I want to do 256. Take a look at the gradient accumulation size. It's going to change it to 32 because of the calculations for the batch size and gradient accumulation, which if you take a look at here, it says suggested 8 batch size cap. And if you divide the 256 by 32, you get 8. And so what the gradient accumulation allows you to do is just simulate larger batch sizes for training. So that's what I did. I did 128.16 for mine. And then for save frequency, I actually had to modify this. So I don't know if it's going to be available in your Tortoise TTS version, but I just set it to the minimum, which was save frequency 1 epoch. And so this will save a model every epoch, and you can stop training and listen to it, or you can stop and come back later at that save interval. All of these other things I left the same. Bits and bytes checked on. And then validation enabled. This is what I was talking about, the validation text file. I didn't enable it, so I just left it here. And then for source model, you just want to leave this as the autoregressive and then resume state path. This is only going to populate if you had done a previous training session or if you want to continue from later. So let me go ahead and explain what that exactly means after I get to the next stage. So after you have all of those set up, what you would end up doing is validating your configuration, and then just saving configuration. So I'm going to go ahead and click save. And so what you would do now is you would go over to run training, and then you would refresh configuration, go into the train.yaml. This is the name of the one that I use here. You can tell by if you go to the dataset down here, you want to make sure that the dataset that you created is selected down here. You're going to use that name for the train.yaml. So once you have it in here, you would end up just clicking train, and it's going to launch the training script. And so I'm going to go and cancel this out. So here is the window here. I'm going to cancel that out and relaunch it. So that's just going into the AI voice cloning folder, running the start.bat, and it's going to relaunch the web UI. So here we go. Let's go ahead and refresh the page. And so that is how you would get training up and running for typical Tortoise TTS training. There are a couple of things I do want to cover because I know people have questions or had questions on it. What happens if you stop the model before it finishes training? What happens if you want to continue? Let's say that you had a previous run and you want to continue training the model. What you would end up doing is going to generate configuration, selecting the data set that you want to continue with. Let's go ahead and do Subaru 2 in this case. And then you would click reuse import dataset. So what this ends up doing is now you see this resume state path actually is populated with this training state interval, and this is going to be epoch 501. And then with this resume state path, what you want to do is just click on save configuration and then go to run training, refresh configurations, choose the name, and then continue training. So that's how you would continue training the model if you stopped, or if you stopped for whatever reason, wanted to continue, or even if you wanted to increase the amount of epochs, you could increase the amount of epochs. Let's say we wanted to do 1,000. and then you could train or save the configuration there. Cool. So that was what I did for Japanese and a quick explanation of all of the toggles that I used for the training. And now what I want to do is talk a little bit about fine-tuning the model that you trained on, or fine-tuning that language once you have a model that can actually speak that language. And so that's what I ended up doing with this Subaru model right here. That's the voice that I played in the beginning of the video. Now, let's say that you have a model that you already trained and you want to use that as the base. Well, you set up all of the variables the same, all the parameters the same that you did earlier, but instead, this is going to be just like training the English models actually. So in this case, what you do is you leave text LR ratio at 1 or 0.01. In my case, I left the learning rate at the lowest value, and I'll show you why exactly. And so after changing all of these variables up here, whatever you want it to be, the next important part is you want to change the source model to the model that you successfully trained on the language. For me, that would be this mp3_jp corpus training rate 2 model right here, 1825 gpt.pth. So this was my most successful model. And this is what I would fine tune the voice on. And then, of course, this would be empty on a blank training set. And then what I could do here is save the training configuration and just run through the normal training. And that would fine tune the language on a specific character or a specific voice. Now, I want to go over a couple of nuances, a couple of things, and a couple of tips. So I noticed a couple of things. So if we take a look at this training right here, if I reuse the values that I had here, I set learning rate to max on this training run, which is just Subaru. And if we take a look at the losses, this loss mel goes all the way down to 0 and flattens out. And this is a little bit of overtraining because the output from this model sounds pretty bad. Now, if we go ahead and do that in comparison, here is Subaru_training 2. What I ended up doing for this model, let's go ahead and change to that dataset, reuse import dataset, was the lower learning rate. And if we take a look at the losses here, now we have a mel curve that did not go to 0, and this one can actually speak Japanese well. So what you don't want is these losses to go to 0 or to go completely down too fast. In my case, just in my observation, this sounded terrible, and here I'll give you a quick sample on how it sounded. I'm going to uncheck this run the outputted audio through RVC. That's how I was getting the audio to sound pretty close to the original voice files. Talk about that in the RVC update video. Now let's go ahead and generate an audio sample from this, and let's take a listen to it.
許す許さないの話になるなら、俺は絶対にお前を許せない。でもそれは俺の心の問題だ。
So if you take a listen to that audio file, it sounds like the output is underwater, very low quality, and not too good at all. What I noticed was that it seemed to have broke the model by putting the learning rate too high, which I'm attributing to overtraining. And so that's why for me, when I reduce the learning rate, it's traveling along the gradient at a little bit of a slower pace and doesn't completely destroy the model for producing mel spectrograms. So this is what we've got for the loss metrics here. And you'll just have to play around with that for the learning rate in this case. Now, there is one more thing that I do want to talk about with a little bit of a glitch that I don't understand or haven't figured out the root cause for. But let's take a look at this JP Corpus training rate 2 graph. If you take a look at this graph, it looks like a blob of red and green. And what ended up happening, why this ended up happening, was I kept having to restart the model because Tortoise TTS and AI voice cloning was crashing during mid-training. So I'm not sure why it ended up crashing mid-training, why it kept crashing. So that is one thing that might happen if you're training on a dataset that is very large. It might crash. And so that's why I ended up modifying the Gradio interface to allow me to put in partial save frequencies for the epochs so that it's not trying to save at such a long interval. So instead of saving every 3 to 4 hours, it's saving every 10 minutes. But with that comes a lot of extra space that it's saving. So that's what ended up happening here. And I wasn't able to find the root cause for it. So that's just one thing that might happen for Tortoise TTS if you're training in this Gradio interface. All right, so that is a lot of information. I just threw that out there. That is all the information that is in my head, at least, for what I did to train the Japanese model and kind of what I learned through this training. So these are just some ideas. It's not a cut out guide on how to get the perfect language trained up, but I hope it is a little bit of some insight on how you might be able to train other languages on Tortoise TTS. So I will be playing a little bit more around with this for Japanese, of course, because I've got some projects that I need for Japanese TTS, and I'll keep you guys updated on that. But yeah, thank you so much for watching this video. Thank you so much to the members of the channel as well for supporting me in my work, and I very much appreciate it. If you guys have any questions, let me know down in the comments below. I'm generally pretty active the first couple of days on my YouTube videos, and yeah, so see you guys later. Good luck.